Okay, and welcome back, students who are taking Math for Business and Finance and Math Applications, and we are working on the assigned problems, the summary practice test problems for Chapter 22, and all we have left to do is 6, 7, and 8, and we're done with the textbook. All right, so let's get to it here. All right, so it says Laser Corporation reported record profits of 30%. It's stated in the report that the cost of sales was 40% with expenses of 30%. Prepare a circle graph for laser. Okay. All right. We have, all right, the cost of goods sold is 40%, and expenses are 30%, and profits are 30%. Okay. Now, we know that in a circle, there's 360 degrees. Okay. Remember, that represents 100%. Here we've got 30, and 30 is 60, and 40 is 100, right? But how do we know how to apportion those within our graph? I mean, you can't just, I mean, you can quickly, just draw that in, but you're going to have to designate exactly how much each area is, and how do you go about doing that when it doesn't tell you that? Okay. I mean, it tells you that profits 30, expenses are 30, and cost of goods sold is 40. But how do you know how much they are? Well, if a circle is, is 360 degrees, okay, we can multiply the 40% by the 360 degrees, the 30% by 360 degrees, and the profit by 360 degrees, okay, in order to determine how many degrees each is. So 40 times 360 degrees times 360 is 144 degrees, okay, and that means I could do this either two ways. I could take 30 times the 360 and I get 108, which is probably the way I would do it. And of course, that one's going to be 108 also. Or I could have taken the 360 degrees, subtracted the 144, which gave me 216. And since they're both equal at 30%, I could have just divided by 2 and still come up with 108 degrees. But that's the little bit more difficult way of doing it. I could have just done one calculation here and come up with 108. So that means this one here is 108 degrees for expenses, and it's up to you to decide where you're going to put them. My profit is 108 degrees, and my cost of goods sold is going to be 144 degrees. Now, even though I just hand drew in the three sections of the circle, you do have to label them in order to be able to make it relative. I mean, if you had computer programs, yeah, I probably would have made that one look sort of exactly like that one, and made this 144 degree one look a little bit larger, okay? But that's because you're using a computer program. And you have the ability to do that. But if you're doing it by hand, it would have been just as easy to just section it off. And but you do have to put in the amounts in order to be able to make everything relative. Okay, so that's creating the circle graph or a pie chart. Okay, number 7. Today a new Explorer costs $39,900. Explorers cost $24,000. In 1990. Today, okay, so right here it should have said in 1990. Explorers cost $24,000. What is the price relative to the nearest 10th percent? Okay. Well, price relative is exactly that. It's just a ratio. 39,900 over 24,000. And the 24,000 goes in the denominator because that's the basis for, what you're looking for, the price relative, okay? So if you're, it's one number, it's very simple. It's a ratio, one over the other, but you have to, what is the base that you're looking at? You're looking at whatever is relative. In comparison, maybe, is a better word. I'm trying to compare today with what was in 1990. Okay, so I'm comparing the 39.9 to the 24,000. So the 24,000 is what goes in the denominator. And whatever I get, 39.9 divided by 24,000, gives me 1.6625. And I multiply that by 100 to convert the decimal into percentage. And that's going to give me 166, and it's rounding to the nearest tenth, so 166.3, okay, percent. All right, and the last problem in the book, and of course it would have to be calculate the standard deviation, but at least there's a small set of data. Okay, now remember, in calculating a standard deviation, I'm going to go back to the optional problem, the drill problem, the optional one, problem number 2, 3, 4, let's see here, 8 and 9, okay, and let's see here, okay, and that's mean, right? Just skimming through. Okay, so go back and, after I do this, if you still don't understand, go back and review problems 2, 3, 4, 8, 9, the drill problems, the optional ones. That'll cover, calculating a standard deviation. And especially in this case here, number 9 happens to be relevant, I think, because in that one I had said, like I know problems 8 and 9, they had said, the problem had said to calculate the mean and the standard deviation, okay? And in problem 9, I had pointed out by saying, well, what happens if the problem just says calculate the standard deviation? And I had pointed out that statistics, one concept builds upon the other, meaning you have to know how to calculate the mean first in order to be able to do the standard deviation, right? Even though the problem doesn't tell you to do the mean, right? And if it tells you to do the standard deviation, you're going to have to know to calculate that mean. Well, it just so happens in the summary practice test, right? That's exactly what's happening. The problem here says calculate the standard deviation for the following set of data. It doesn't tell you to calculate the mean. It's up to you to know that you have to calculate the mean in order to be able to calculate the standard deviation. Okay, so go back and watch problem number 9, and explain that again, all right? But here's the actual working example of it. So, first thing I have to do is I have to figure out what the mean is, right? Right, the mean is nothing more than an average, so I'm going to add up all of these numbers and divide by 1, 2, 3, 4, 5. There's 6 points of data there, okay? So I'm going to end up dividing by 6, right? So 7 and 2 is 9, and 8 is 17, and 3 is 20, and 10 is 30. So 30 divided by the 6 points of data gives me a mean of 5. Okay. Now, I have to find the sum of the squared deviations. And if you had looked at problem number 2 in the drill problems, or even in the tables, the illustrations in the chapter itself, you would have found that what they did was they arranged the information by data. They actually created a chart and then had a data minus the mean, and then they had the data minus the mean, and that is squared. Okay, so it just, it's sort of like in a table format in order for you to be able to work through the steps. And in the theory, I went step by step. Number one was the mean, two, is the data minus the mean, and then, that's the deviation, okay? And then data minus the mean, the deviation squared, okay? And so we could create the table by listing the data, right? And we list it in the order as they from lowest to highest. So 2, 3, 3, 5, 7, and 10. Okay, so that's my data. Now my my deviation is my data minus the mean. Well, 2 minus the mean of 5 gives me a minus 3. 3 minus 5 gives me a minus 2. 3 minus 5 gives me a minus 2. 5 minus 5 gives me 0. 7 minus 5 gives me 2. And 10 minus 5 gives me 5. Right, so these here are my deviations from the mean. Now, my next step is to square. That's what we're doing right here. We're squaring that deviation. So I'm taking the minus 3 and I'm squaring it, right? Well, 3 times 3 is 9, and since a minus times a minus is a plus, it's going to be a plus 9. Right? Minus 2 squared is 2 times 2 is a 4, and since it's a minus times a minus, I still get a plus 4. So minus 2 squared is 4. 0 squared obviously is 0, right? 2 squared is 4, and 5 squared is 25. And then what we're doing is we're going to add them all up. All right, so we've got 9 and 8 is 17, 21, 46. All right, so that's the sum of all of those. Okay, now doing all of that, okay, I did it in a table format, and and I'm doing all of the math. But the concept that you want to try to remember is it's the sum of the squared deviation. Okay, and we kind of like do this backwards. We do step 1, we find out the deviations, okay, which is what we did right here, right? We found out what the deviations were. The number 2, we squared them, right, which is what we have right here, okay? And the number 3, we took the sum, which was adding them all up, and we got 46, right? So now we take that 46, all right, and we have to divide by n minus 1, all right? Well, what is n? N is the number of data points, and we know that the number of data points is 6, right? There's 1, 2, 3, 4, 5, 6 data points. So I take 6 minus 1, which is 5, right? I have 46 divided by 5, and that gives me 9. Let me change color here. That gives me 9.2, right? Now that I have the 9.2, I'm going to take the square root of the 9.2. And remember, to do that, all we're doing is punching in our basic calculator. We're taking the 9.2, entering it in, and then hitting the square root key. And when we do that, and we're rounding the answer to the nearest tenth, so let's see here, 9.2 square root, I actually get 3.033, and since we're rounding to the nearest tenth, I'm going to round down, so my standard deviation is 3.0 for my standard deviation. Okay, so that's my answer, 3.0. Right? Okay, so I'm not going to go back over this because again, there was the drill problems 2, 3, I think it was 4, 8, and 9, right? Especially numbers 8 and 9. All right, those are the most helpful. 2 and 3, you see me doing all of the math like you see me doing it here. Okay, but doing problems 8 and 9, I really don't go over all of the math. I point out that trying to remember how to do the standard deviation is first you have to, you find the mean, then you do the sum of the squared deviations, okay? And when you get that sum, right, then you divide by the n minus 1, right? And whatever you get for that number, you take the square root of, okay? And then that gives you your standard deviation, all right? So that's it. Watch those other videos if you're having a little bit of difficult time, all right? Definitely try to work through them, and if you still don't understand the concepts, feel free to telephone and speak with an instructor. And with that, that's the last problem in the textbook. So you've made it, and I believe like the next thing you have to do would be to take a lesson exam and of course a proctor or final exam. So good luck in those exams, and we'll see you when we get over to business statistics. Okay? All right, thanks and have a great day.